Okay, hello everybody. We're gonna start by going over some of the review problems that I didn't get to do on Friday or in any of my sessions. So first, we're gonna start off with this number 3 from the test, where it's saying to find the equation of a tangent line, which we know is y minus y1 equals mx minus x1. I'll just switch a different color. So here we are given only our x, so we're going to go ahead and find our y by just plugging in 1. So 1 plus 1 squared, which is simply 1 over 1 plus 1, which is just 1 over 2. So now we have our x and our y. Now we want to go ahead and find our m. And to find our m, we have to find the derivative of the function and plug in our x. So in this case, our function is square root of x over 1 plus x squared. I'm going to go ahead and rewrite this to x to the power 1/2 times 1 plus x squared to the power of -1. And just find the derivative of this. So we know this is going to be a product rule. So my f is going to be x to the power of 1/2. My g is going to be 1 plus x squared to -1. My f prime is 1/2 x to the power of -1/2, or 1 over 2 root x. My g prime is going to be a chain rule, and hopefully you guys know chain rule. It's going to be 1 with your same inside times the derivative of your inside. So now plugging everything in into fg plus g prime f, we're going to get 1 over 2 root x times 1 plus x squared to -1 plus g prime f. So I'm going to just go ahead and write f first. So -1 1 plus x squared -2 times 2x. And then we'll go ahead and plug in our 1. So here we get 1. 2 times 1 is just 2. And then 1 plus 1 to -1 is basically saying 1/2 times 1/2 plus 1 times -1. 1 plus 1 squared, which is just 1 to -2 times 2 times 1. So this says it's going to be -1 times 1 over 2 squared, which is 1/4. Oops. Times 2, which is -1 times 1/4 times 2, which is going to be -2 over 4, which is -1/2. So we get 1/4 on the left, and we get 1/4 on the left and -2/4 on the right. So we're left with -1/4. So this is our m. So now we get y minus 1/2 equals -1/4 x minus 1. And that's your equation of a tangent line. Some of you guys wanted to find this problem again, so we'll go ahead and do it. The easiest way to go about this problem is ln. So you have ln y equals ln of your whole function. I'm not going to rewrite it, to the power 7. We'll go ahead and move our power to the front and distribute. So we have y prime over y equals 7 ln of x squared plus 1 to the 5th plus, because it is a multiplication, ln of 2x minus 3 to the power 4 minus, because now we're dividing, so ln of x4 plus 4x squared plus 4 to the power of 6 minus ln of 3x squared plus 5 to the power of 1/2. So now we want to move all of our powers to the front for every term. We're left with y prime over y equals 7 of 5 ln x squared plus 1 plus 4 ln of 2x minus 3 minus 6 ln x4 plus 4x squared plus 4 minus 1/2 ln of 3x squared plus 5. Now I want to go ahead and derive all of these, which basically gives you y prime over y equals 7. And these are all going to be ln u, and the derivative of ln u is u prime over u. So this is going to be your u. So you have to find the derivative of each inside and then divide it by itself. In which case, the derivative of this is just simply 2x over x squared plus 1 plus 4 of 2x plus, 2x minus 3 plus, sorry, 4x cubed plus 8x over x to the 4 plus 4x squared plus 4 minus 1/2 of 6x over 3x squared plus 5. And then you could either leave it like that or simplify, whichever you want. And then you multiply everything times y to get y by itself, y, and then basically everything we wrote. And then you could either leave it as this, I assume, or you replace y with your original function. And that's how you do that problem. This is another one that a lot of people asked me for. So in this one, we know that we have an equation, and based off SOHCAHTOA, we have cosine equals 50 over x, because cosine is adjacent over hypotenuse. So we want to go ahead and move our x to the front so we could solve for x. So we multiply x on both sides, we get x cosine equals 50, and then we divide by cosine, so you get x equals 50 times 1 over cosine, which, if you know the trig identity, this is x equals 50 secant theta. Okay, reading at the problem, we're given what are we given? We're given d theta dt, d theta dt being 0.01 radians per minute, and we're given theta is equal to 0.5. Okay, so now we have our function and we broke down our word problem. So now we want to derive. So derivative of x is just simply dx over dt equals 50 is our constant, and the derivative of secant theta is secant theta tan theta, and now we just want d theta dt because we derive with respect to theta. Now all we do is simply plug in all of our values. So dx dt is equal to 50 secant of 0.5 tangent of 0.5 times 0.01, and that should be your answer. Okay, now we want to do a spherical balloon. Okay, so for this problem, we're gonna break it down first. We know that it's being inflated. It says that the radius is increasing at a rate of 2r, so dr dt is equal to 2 over r. It's asking us for the volume. It's unknown, but we know that it's increasing, so it should be positive. And it's telling us our r is equal to 4. So that's it. And now we know for a spherical surface, we get volume is 4/3 pi r cubed. And now we take our derivative, so dv over dt equals 4/3 pi is our constant, and we just derive the r. So we get 3r squared dr dt, since we derive with respect to r, and we simply plug in. So dv over dt equals 4/3 pi times 3, and then our r is 4, so 4 squared times 2 over 4, or 2 over r, whichever you prefer. So here, our 3's can cancel, So we're left with dv over dt is equals to 4 pi times 16 times 1/2, which is the same thing as saying 64 pi times 1/2, which is equals to 32 pi. Okay. Next, given this the shape, given that it's a circle and that the area is increasing at said rate, so we have dA over dt is equal to 9 pi. It's asking us how fast the radius will be increasing, so dr over dt is unknown and it's positive, and it's giving us the r is 10. So we have to find the area of a circle, which is just simply pi r squared. Take our derivatives, so dA over dt equals pi is our constant, 2r dr d theta. So this is 9 pi equals pi 2 times 10 dr dt. So 9 pi equals 20 pi dr dt, and we simplify by dividing by both sides, so 9 pi over 20 pi equals dr dt, which this is simply just 4.5 equals dr dt. Next problem and final problem. If you guys need more help, just feel free to message me. So here we're given that the radius is increasing, so dr over dt equals 4 centimeters per minute. It's asking us how fast the area is increasing, so dA over dt is equals to 5. And it's a circle, sorry. And then, sorry, dA over dt is unknown. R is 5. There you go. And now we want our area of a circle again. So area equals pi r squared. Take our derivatives. dA over dt equals pi of 2r dr dt. dA over dt equals pi of 2 times 5 times 4, or dA dt is just 10 times 4, or 10 times 4, which is just 40 pi. And that's it. Okay, last problem. I'm going to do number 5 on that worksheet. We are given that the rate that's increasing is dx dt equals 5. I'm going to go ahead and label everything. So our x is going to be our distance in, like, from the person to the lamppost. Our s is going to be the shadow length, I guess. Okay, so drawing this, the word is our lamppost is 20 feet tall, and our distance is going to be the distance from the guy in the lamppost plus the shadow. For our smaller triangle, we're going to get the 7 feet tall person, and then the shadow is going to be the bottom. So this is going to be for lamp, this is going to be for the person. In which case we could scale these basically. So the heights divided by the bases is equal to the height of the person and then the base as well. So now we're going to solve for s. So by solving for s, we're going to cross multiply. So we get 20s equals 7x plus s. We'll distribute our 7. So we get 20s equals 7x plus 7s. Then subtract 7 on both sides, so we could get the 20s by itself, or the s by itself. Simplifies to 13s equals 7x. Now s equals 7 over 13x. Once we get to this point, we could derive, so we get ds over dt equals 7/13 dx over dt, in which now we just plug in our dx dt, which we said was 5. So ds over dt equals 7/13 times 5, which is the same thing as saying 35 over 13. And that is your answer.